Hello. Okay, so hopefully we all remember the Pythagorean theorem and how to use it. So the Pythagorean theorem is a squared plus b squared equals c squared. So you can use this in a certain type of triangle. Hopefully you know what that is. A right triangle. So we have a triangle with a 90-degree angle. So that's when we can use this. So the two legs, the two sides that are both next to or touching this right angle are A and B. Those are the two legs. C is always the hypotenuse, or the side that is on the opposite side of the right angle. So in example 1 here, it's asking us, is this, if A is 6, B is 4, and C is 9, is that a right triangle? In order to figure that out, we do A squared plus B squared equals C squared. If the two sides are equal after I square those numbers and add them, then it is a right triangle. If they're not equal, then it's not. So 6 squared is 36, 4 squared is 16, 9 squared is 81. So 36 plus 16 is 52. And as you can see, 52 does not equal 81. So this is not a right triangle. So what we're going to do next is we're going to figure out what type of triangle this would be if it had these side lengths. So if you remember from a few lessons ago, last unit, I believe, to figure out if this could possibly be a triangle, we had to be able to add the two smallest sides. So in this case, 6 plus 4. And that would have to be bigger than the third side, which is 9. So 6 plus 4 is 10, and 10 is bigger, whoops, wrong side. 10 is bigger than 9. So that means this could possibly be a triangle. So like I said, now we're going to classify what type of triangle it is. So if the two sides are equal, like I said, it would have been a right triangle. If the two sides are not equal, it's either going to be an acute triangle or an obtuse triangle. So an acute triangle means that every single angle, all three angles, are less than 90 degrees. So they're skinnier than 90 degrees. If we have an obtuse triangle, that means we got one angle. It's going to be angle C here. So whatever is opposite of the hypotenuse is going to be bigger or wider than 90 degrees. So in order to figure out if it's an acute triangle, if I add a squared plus b squared and it's bigger than c squared, then it's acute. If I add a squared plus b squared and it's less than c squared, less than 90, no, I was right the first time. It's less than c squared, then it is an obtuse triangle. So let's do an example because I know I totally messed up that explanation. So example 2, tell whether the triangles are right, acute, or obtuse. So again, we're going to do a squared plus b squared, b squared equals c squared. So 6 squared plus 9 squared has to be equal to 5 squared. So right away you can tell that those are not going to be equal to each other. So it's not going to be right. So let's see what type of triangle it is. So if I added up the two smallest sides, 5 and 6, that would be bigger than 9. So it could be a triangle. So they're definitely not equal. 36 plus 81 is 117. So that would be bigger than 25. So if I go back up here, up to the little rule, so a squared plus b squared is the number on the left, that's bigger. So a squared plus b squared is bigger than c squared. That means it's an acute triangle. So it would be acute. So next, on part B, so a squared plus b squared equals c squared. So 24 squared is 576. 16 squared is 256. 29 squared is 841. So if I added these two numbers up, I would get 832. So they're definitely not equal to each other. So this time, a squared plus b squared is less than c squared. So if I go back up here, a squared plus b squared is less than c squared. That's obtuse. So this would be an obtuse triangle. And again, the first thing I should be checking is if the two smallest sides added together are bigger than the third side, which of course this is. 16 plus 24 is 40. It's definitely bigger than 29. So it could be a triangle. All right, example 3. So we got to tell whether the triangles are right, acute, or obtuse again. So 6 squared plus 8 squared equals 10 squared. So 36 plus 64 equals 100. If I add 36 and 64, I do get 100. So the two sides are equal. So that means it's a right triangle. All right, next, a squared plus b squared equals c squared. So they're definitely not going to be equal because I'm adding two numbers that are way bigger than the third number. So 18 squared is 324. 15 squared is 225. 4 squared is 16. So when I add up these two numbers, I get 549 does not equal 16. So 549 is definitely bigger than 16. So again, if a squared plus b squared is bigger, it's an acute triangle. And then finally on example 4, can segments with length of square root of 1, square root of 7, and square root of 10 form a triangle? If so, what type of triangle would it be? All right, so again, first thing we got to do is add up the two smallest sides. So square root of 1 is just 1. Square root of 7 is about 2.65. Square root of 10 is about 3.16. So 1 plus 2.65 is, whoops, let's erase that, is bigger than 3.16. So it could be a triangle. So the answer to this is yes. Now we got to figure out what type of triangle it would be. So we got, not angle, a squared plus b squared equals c squared. So 1 squared is just 1. Square root of 7 squared. So when you have a square root squared, those two just cancel each other out, so you get 7. So let me show you what this would look like. So square root of 7 squared would look like this. Square root of 7 times 7. Pair of 7s, one goes away, the other one comes out, so it equals 7. So anytime you have a square root squared, it just equals the number inside. So that would equal 10. So 1 plus 7 is 8. 8 is less than 10, so if a squared plus b squared is less than the number, a squared plus b squared is less than c squared, so that means it's obtuse.